In this example, we're going to simplify radical expressions using the quotient rule. Now, the quotient rule is a form of division or fraction. So anytime you have something in fraction form, you're going to be applying the quotient rule, and that's only if they have the same indexes. Again, just like with the product rule, the quotient rules, they must have the same index. So what this rule states that is, if you have a radical on top and a radical on the bottom, and they both have the same index, that you can simply divide them, top divided by the bottom. Now you can see it in two different forms where you can see both numbers can both be under the whole umbrella of the radical, such as in the first case. Or you may see a radical problem where the top has its own radical symbol and the bottom has its own radical symbol for the number, but still both have the same index. So let's take a look at example 1. They each have their own radical symbol, but again, the indexes are the same. It's square root. So instead of finding the square root of the top and then finding the square root of the bottom, the quotient rule states that you can simply take the numbers and top divided by the bottom. So 75 divided by 3 is equal to 25, but we're still it's going to remain under the radical symbol. We still have the radical symbol there. So your 75 divided by 3 is going to give me square root of 25. And now we can go ahead and solve it. The square root of 25 is 5. Now I just want to make a note that you don't need to write that extra step as I did in this example here of putting both the top and bottom underneath the whole umbrella of that radical symbol. I'm just showing you that, especially when you do your homework in my math lab there, you may see some problems where the numerator and the denominator, that value has the radical symbol over it by itself, or you may see that they place the whole thing as a fraction under the radical symbol. That either way is fine. Let's take a look at our second example here. Both the top and the bottom have the same index of 2, therefore they're both square roots, so we can apply the quotient rule, which is top divided by the bottom. So you're going to do the numerical part, which is 48 divided by 3, which is going to give you 16. And then with the variables, applying the quotient rule, keep the base of a, top, take away the bottom, is going to give you a to the 6 powers, still under the radical symbol. So what we're going to have is 16 a to the 6 power once we simplify that by doing top divided by the bottom. So now we can just go ahead and solve it, and the square root of 16a to the 6 power is what? You got it, that's correct. It is 4a cubed. And there you have it, applying the quotient rule. Let's do 2 more examples applying the quotient rule. So here we have the top and the bottom both have their own radical symbol, but they're both square root. So we can simply just place them all under the umbrella there. It would be your x's top, take away the bottom using the quotient rule. Y, top, take away the bottom. So for my x's, I'm going to have 5 take away 1. For my y's, I'm going to have 3 take away 1. Go ahead and simplify that further. That's going to give you x to the 4th power, y squared. And then now finding the square root of that. The square root of x to the 4th power is x squared. The square root of y squared is y, which leaves me with an answer of x squared y. Let's go to the next example. Both the top and the bottom, they have the same index of 3, so they're both cube roots, so it is okay to apply the quotient rule. It meets the criteria there. So all we need to do is to simply top divided by the bottom. For your numerical part, 54 divided by 2. For the variables, you're going to keep your base of m, top take away the bottom, and that's going to leave you with the cube root of 27, m to the 6th power. And now we can go ahead and solve that. The cube root of 27 is 3. The cube root of m to the 6th power is m squared. So our answer is 3m squared. The quotient rule.